Alright, in this video, I'm gonna focus on double effects and the calculation on double effects. But before we move into the calculation here, let's take the definition of double effects. Alright, okay, please write. Double effect can be defined as a phenomenon of change. Double effect can be defined as a phenomenon of change of sound or frequency. Double effect can be defined as a phenomenon of change of sound or frequency. So our target definition here is change of sound or frequency. Change of sound of frequency. So the change of frequency, the phenomenon is said to be double effect. That is Doppler effect. Please take note. The change of frequency is said to be double effects. Please take note. So now let's try to know the purpose of double effects. Now the main purpose of double effects is to calculate the observer frequency and to be able to calculate the bit frequency. Please take note of this. The purpose of double effect is to calculate the observer frequency and the bit frequency. So now let's look into observer frequency here. Okay, now the formula for observer frequency is said to be F naught is equal to Fs into V plus or minus V naught over V plus or minus Vs. Please take note. Okay, now this is the formula for double the frequency of observer. Please take note. This is the formula for frequency observer in double effect. So let's know what F naught stands for. Let's know what Fs stands for. Let's know what V and V naught and also Vs stands for. Please take note. And later we can now know the sign convention of double effect. So class, the V naught here is said to be observer frequency. Please take note. The Vs is said to be source frequency. All right. The V, that is the velocity there, is said to be velocity of wave or sound. Velocity of wave or sound. Please take note. The V naught here is said to be observer velocity. Please take note. The Vs is said to be source velocity. All right. Now the next we are going to look into here is the definition of observer and source. So now let's know what a source is, or let's know who a source is. Source can either be an object, source can either be a person. Please take note. Source can either be an object, source can either be a person. Please take note. So now let's know what source is. Now the source is the producer of sound. So if I have a siren and I have a car, now that siren that is producing the sound is said to be the source, while the car that is close to the source or the siren is called the observer. Please take note. Just know that the observer is the producer of sound. The observer is the producer of sound. Okay, so before now, let's know when this formula can either be plus or minus, or let's know when this can be plus or minus. For us to know when the formula can either be plus or can either be minus, let's consider the sign convention in double effect. Sign convention on double effect. All right, sign convention. Okay, let's take the sign convention on double effect. Sign convention okay, now class, before we take the sign convention here on double effect, this is what you have to know, that at every point in double effect, the observer is always located at this point here, that's at the left, while the source is always located at the right. Please take notes. So if I have something like this, this is observer. Please take notes. This is source. Please take notes. I'm sorry for this. So sometimes the observer this observer might be towards the source. We are going to know the sign or the velocity at that point, or the source might be towards the observer, or this guy might be away from the observer, or the observer might be away from the source. So now let's know the sign convention on each of them here. So before we know the sign convention here, this is what you should understand. You should understand your Cartesian plane. When you have a Cartesian plane like this is your Cartesian plane. Anything in this direction should be plus s, and anything in this direction should be what? Minus s. Please take note. So if this guy or source is moving towards the observer, that means the velocity moving here is the velocity of source. So I'm going to have velocity of source here, while this guy is going to be stationary. So that means if the observer is stationary at that point, that means v of naught will be equal to 0. So our v of s is going to be equal to what, this class? Minus v of s. Why is it minus? Because it is focusing, or the direction is at the negative part. Please take note. So now let's take the first sign convention here. Number one, let's take the first sign convention here. Okay. Number one, when the source is towards the observer, when the source is towards the observer, please take note. So if the source is towards, listen, if the source is towards the observer here, that means if you have something like this, a sketch, you have to get a sketch like this. This is your sketch. This is your sketch. Of course, the observer is always here, the source is here. So if the source, which is this, is towards the observer, it means that the moving velocity will be from the source. So that means our v of s will be equal to, and we have to look into the direction. What direction? Is it negative or positive? It's negative. So we have this to be minus vs. Please take note. So if this guy here, remember, if this source here is moving, that means this should be at rest. So velocity at rest or stationary should be v naught, which is from observer velocity, should be equal to what? 0. Please take note. All right. this source is moving towards the observer. Observer will be stationary. The moving velocity will be at source. So that means v of s is equal to minus v of s. The minus is as a result of the direction. The direction is based on the negative direction. When you look into this Cartesian plane, this direction is minus s. Please take notes. Okay. Now let's look into the next one here. Maybe when the observer is moving towards the source. Okay. Let's take the second sign convention here. Okay. But in case you have not subscribed to our YouTube channel, the only thing you have to do here to get the full video of this particular topic is to hit the subscribe button, and also you can share, you can also like. Okay, now let's try to move into the second one here, class. Now the second one here, number 2, when the source is towards the observer. So let's look into the pictorial sketch on when the source is towards the observer. Okay, so I have this. Remember, always here is always your observer, here is always your source. So if this when the observer is towards, okay, sorry for that. Okay, if you have watched this video to this point, just try to tell me the mistake here. What mistake? Okay, now let me just explain this part here. When the observer is towards the source, that is the second one here. Okay, when the observer is towards the source. Okay, that is this observer here. So the observer is towards the source. Okay, so the moving velocity will be from the observer. So our v of naught will be equal to plus v naught. Why plus v naught? The direction is focusing on positive direction. Please take note. So if observer is moving, that means the source velocity should be stationary. That is v of s will be equal to 0. Please take it. So the next one here, let's take the next one here, the third one here. When the source is away from the observer. So if the source is away from the observer, let's look into the pictorial sketch here to understand this statement. Okay, so if the this is the observer, always this is the source. So the source is away, that means the source is away here. That is the velocity moving here is from the source, that is the v. All right, 4, that is the sign convention. Okay, 4, when the observer is away from the source. Okay, now let's look into the picture here to understand the velocity moving and the velocity at rest. Let's look into the picture to understand the velocity moving and the velocity at rest. Okay, so always the observer is always at your left observer, your right source. Please take note. So the observer is away from the source, that means it's away from the source. So the moving velocity will be focusing on observer, that is f naught. Okay, will be equal to minus equal to minus f naught. Okay, while the v of s is equal to 0 here. Please take it. So let's take example 1 here to apply on this sign convention. Example 1, please. Then is question 1 on double effects. Question 1 on double effects. Let's take question 1 here. Because they said sub, that is sub, sorry. So sub A in bracket source travels at 8.00 meter per second, emitting at a frequency of 1400 hence. Full stop here. Okay. The speed of sound in the water, speed of sound in the water is 1533 meter per second. Okay, full stop here. Sub B in bracket observer travels at 9.00 meter per second in opposite direction. Sorry, in opposite direction. Full stop here. All right. What is the frequency held? What is the frequency held by both? What is the frequency held by both subs? Sorry. By both source. Sorry, subs, not source, sorry. Okay, first of all, let's try to understand this question here before we solve this. But for you to get the full video here, there is the solution to this. You hit the subscribe button. You can also share. Okay, let's get the next to get the next video here. That is to get the solution to this. You hit the subscribe button to get the full video on this. Okay, thank you so much.